It's about, I've counted something like 30, 40 people by the rule of thumb, which is a pretty interesting number for a futuristic kind of talk like this one, which is about ASP.NET Blazor. Blazor is not even a beta product. It's only recently it was qualified as a technology that Microsoft is actively working on. Up until a few, let's say, weeks ago, it was only an experimental framework. So we're playing with this, but we have no idea whether it will ever reach an end, it will ever come to an end, and which end it will ultimately be. Blazor is partly related to the 3.0 big thing, in the sense that there is a small segment, and in my humble opinion, the least interesting segment of the Blazor thing that is slated to ship with the whole ASP.NET 3.0 thing. But we will talk, of course, about this segment that will be the first to ship, to be released in only a few weeks, because 3.0, ASP.NET Core 3.0 will be released according to what was unveiled at Build last week in the September or October time frame. The whole Blazor thing, however, will come later, probably will come next year, because there is not even, I think, a preview. There is a preview, but I mean, it's not even a beta quality kind of thing. We will see that, demos work, a number of things can be done, but for example, Visual Studio has a lot of issues in any attempt to try to do IntelliSense or to detect classes, methods, bindings, and things like that. What is Blazor? To cut the long story short, is Angular in C#. That's it. Oh, Silverlight. No, it's not Silverlight. Okay, it's not Silverlight, but it has some good analogy with the idea. Okay, it's the same idea. Microsoft will kill me. Okay, anybody from Microsoft here? Okay, so Microsoft will kill me if they hear me saying that it's okay, it's a Silverlight. You know Silverlight? Okay, that's it. It's better Silverlight. Honestly, when I wrote the first article on Blazor months ago for MSDN magazine, I put this sentence: it's like Silverlight, blah blah blah, and then the PM of Blazor, the program manager of Blazor, kindly try to, to suggest I use a different wording. Well, but not because it's not true what you're saying, because it's exactly that, but because people have such bad memories of Silverlight that, my experience actually is quite different with Silverlight. People loved it, I mean, for what I can say. The issue is that Microsoft abruptly terminated it overnight. And that created quite a bit of an issue, to several companies. This is the bad memory of Silverlight that people have. So anyway, regardless that, there is conceptually is the same thing. So running C# code right in the browser. But so in much the same way Silverlight did. But there is, however, a huge difference between Blazor and Silverlight. And this has to do with the way that browsers allow external code to be hosted. Experimental framework that brings C# into any browsers without a plugin. This is the key difference, because from the time in which Silverlight was released, and we are talking about, wow, over 10 years ago. We are talking about 2007. If I remember correctly, it was 2008, so 11 years ago, when I recorded a video course on Silverlight 2 because Silverlight 2 was the first version of Silverlight seriously usable for building true front ends. So it's 11 years ago. In 11 years, browsers underwent a relevant, silent revolution that has, in a way, created an alternative to plugins to host external code. We'll get into details in just a few moments, but I want to make a second point here. So Blazor, which is a way to run C# code in any browsers, without a plugin, combines, in the end, a single-page application, whatever means to you the concept of a single-page application, SPA, Angular, React, those things, detached, okay, independent client-side front-end running in the browser with C# code instead of TypeScript, instead of JavaScript, instead of all the dialects, JSX and so forth, over JavaScript, and without transpilers, webpackers, blah, 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 blah. It's plain ASP.NET style coding using the familiar technologies of the ASP.NET stack, Razor, for example. But also those features of Razor new in ASP.NET Core, and one in particular, little known, but still relevant. It's called tag helpers. Ever heard about tag helpers in ASP.NET Core? Only one, maybe two? Okay, quite a few. 5, 6, not that many. But anyway, a tag helper is essentially the infrastructure, the C#-based infrastructure for creating custom controls, components, that you can mix and match with HTML tags in a Razor source code. So you can have your own custom markup elements in your Razor source code, whose internal behavior and the output they produce is under, and also the syntax they expose, templates, bindings, and so forth, is controls, attributes, whatever, is under your total control. So in the end, Blazor will take on an extended version of tag helpers to create components within the Razor so that it offers exactly the same set of overall capabilities you find in Angular, in React. You can componentize your user interface using data binding, using templates, bidirectional binding as well, but using C# as the glue code. Okay, what is a Blazor application? And I still have to make the point of how is it possible to run C# code without a plugin? A Blazor application is apparently a regular ASP.NET Core project. Once compiled, it produces a set of files, assemblies, and JS files, and CSS files, and your own application files, which are downloaded into the browser, and then they are run. There is no interaction after that with the server. After the first download, there is no interaction between the client, the browser, and the server, except if an explicit HTTP request or gRPC request is made towards a remote server. A Blazor site can be served by any web server, because it's just ASP.NET, on any platform, and that's important, can be consumed by any browsers that support WebAssembly, WASM. That is the key thing that removes entirely any dependency on plugins, because in 10 years, browsers have evolved so that essentially they introduced an additional shell to be able to import external code. So historically, browsers had just one shell, one sandbox, that's the term, a technical term, one sandbox to run JavaScript code. When we say JavaScript runs a sandbox, it means that the browser architecture has an internal box in which they can load and run using whatever technologies needs to be run, that in case of JavaScript, the interpreter, Chromium V8 or whatever, these days. So JavaScript runs a sandbox. They, over time, created an additional parallel sandbox to run Flash applications or Silverlight applications. So browsers were exposing just the plumbing for companies to create a plugin according to specification that could be hosted by browsers. And this is what Microsoft and Adobe did for Flash and Silverlight. This is still, I think, supported, but nobody cares about that. Over time, in this past 10 years, a fourth sandbox was created and implemented by most browsers, which is the sandbox where you run WebAssembly code. And again, so in terms of security, there is no difference at all between JavaScript and WebAssembly. WebAssembly is used to run C#. It doesn't matter. It's the same, because everything runs in a sandbox, in the same kind of sandbox as JavaScript. Okay? So this is something to be printed in your mind, in your manager's mind. There are no security issues whatsoever, period. So in these 10 years, since Silverlight, we tried as an industry to go well beyond the full page refresh problem. We introduced Ajax, and then jQuery to make Ajax easier. In ASP.NET, we also had partial rendering. And then, okay, regardless of the fanciful technologies and libraries and this and that, it's all about finding the most effective way for client-side data binding. That's it. So you take from a remote location down a collection of data, mostly JSON serialized, and you need to find a way to render, to inject those data into an HTML template. This is client-side data binding. This is what React, Angular, Vue.js, and many other libraries less popular than these three actually do. And altogether, this brings to SPA. SPA is much more than just client-side data binding, because it also includes routing, navigation in the client-side part of the application. And then it's all about infrastructure for building components, client-side data binding, and routing. This is what we have on the client side, and Blazor is good at all of those things. Then still remains a business decision whether to go with Blazor or Angular or this or that, but keep in mind that when ready, when released, Blazor is at the same logical level as Angular. More Angular than React. React is a very rich client-side data binding library. Angular is a development platform. Blazor is closer conceptually to Angular than it is to Vue.js or React. But anyway, it's still a framework to build SPAs. Okay, so how does it work? Again, it's a plain .NET standard library. It has a program .main entry point, and it works by downloading on the browser side the .NET runtime, the special version of the .NET runtime compiled as WebAssembly. So it's at the moment is mono compiled as WebAssembly, one of the efforts, the wonderful projects run at Xamarin. That's it at the moment. It will be, as Microsoft makes progress on the core platform, .NET 5, or those things we may have heard last week, we will have the .NET Core targeting also the WebAssembly, let's say, open environment, in much the same way it targets Linux or this or that, iOS or whatever. So the code that you write in C# runs natively, because the WebAssembly only serves the purpose of bringing the virtual machine running in the browser. Then the application sends, in addition to the mono-wasm file, also sends the assembly, the actual assembly of your server-side developed project. So your code is a .NET assembly, which is processed within the WebAssembly-based version of the .NET runtime. Code runs in a sandbox in exactly the same way as JavaScript does. Here you go. This is a screenshot taken from Fiddler when a sample, the home page of a sample application based on Blazor runs. It's exactly the Hello World application I will go to show in just a few moments. The first request is for the sample page. Fetch data is one of the links of the endpoints in the demo app. So Bootstrap CSS files are downloaded as it happens with a regular page. And then there is that /framework blazor.webassembly.js. That is the runtime, the .NET virtual machine, downloaded as a WebAssembly. I'm sorry, stupid me. WebAssembly.js is not yet WASM. It's the loader of the mono assembly. Other CSS, all the requests have been interleaved. The Blazor boot JSON file with configuration information. Finally, mono.js and mono-wasm. Okay, so those are the files that bring the virtual machine, and then highlighted, you see all the DLLs of the sample application, the Hello World application that I wrote. You see there are a bunch of DLLs from the .NET Core, the ASP.NET Core. There are some additional files like mono-webassembly.interop.dll. There is, okay, PDB. There is also a sample JSON file. That's it. So the bootstrapper, a JS file, the .NET runtime compiling WebAssembly, and then all the files making up your application. A few more words before we switch to Visual Studio about WebAssembly is a binary instruction format for a stack-based virtual machine. Technically, all virtual machines we have today, Java.NET, are stack-based virtual machine. Of all the popular virtual machines of these days, Dalvik, the Android one, is slightly different, follows a slightly different architecture. So it's not really, those are behind WebAssembly, a different, particular, weird virtual machine. WebAssembly has a compilation target for a number of languages, including Rust, C++, C, and through support offered by browsers, modern browsers, it's just a new browser inside shell for running external code, external plugins, so to speak. It's an open standard. WebAssembly.org. So it's nothing to do like Silverlight, proprietary of Microsoft. It's open standard, WebAssembly.org. Interestingly, there is a group at W3C with representatives from companies behind major browsers, Microsoft, Google, and so forth. And interestingly, in red, a consensus cross browsers, okay? So cross-company, about what WebAssembly should be able to do. This consensus was reached, well, 2 years ago. And the agreement, the consensus says, okay, it is like it is now. It will be like this for the foreseeable future unless some changes prove necessary because of adoption. So we can take from this the message WebAssembly is destined to remain as is for a long time. And if it changes because there is the strict need from the community, arising from the community, for it to change. It's considered, or others say expected to be at some point up to 30% faster than the fastest JavaScript running in Chrome. So the performances we can expect out of a WebAssembly-based client-side code can be significantly better than the best performance we can achieve today with the fastest today's JS engines. So when I say that Blazor is already conceptually on the same level as Angular, conceptually not yet in terms of implementation, consider that it also has this aspect that could make its performance inherently faster. So the dream of 10 years ago of switching away from JavaScript, you know, well, we'll see. Okay, in action. Here we go. I have this application created using one of the standard templates in a Visual Studio 2019. You can also play with Blazor with 2017, but you need to have installed 3.0. There was a minimum preview version of 3.0 you need to have installed. This is because up until a few months ago, so I think it was February or something like that, you could run Blazor applications without the preview of 3.0. But then at some point in this spring, they changed, they switched and made 3.0 only. So 3.0 is a requirement now for running Blazor, regardless of the version of Visual Studio you use. So this is 2019. This is the Hello World application created out of the default template. Now, let's take a look at the project file, because there are a few interesting things to notice. Okay, there is a www root with nothing special, CSS. Sample data is just because of one of the endpoints which contains a JSON file for a demo, so ignore sample data. Index HTML, it's interesting, because index HTML is the super layout, is in a way the super layout of the entire application. The source code of this file is like this. It contains some plain HTML stuff, okay? The title, links, so bootstrap and so forth. And then it has essentially an empty body. So imagine that whatever you will see is injected in the body of this file. So whatever you put around this HTML file will be shared across all possible views of your application. This applies to CSS files, to JS, and to, mostly to JS and to CSS files. A couple of things to notice: the app tag and the script tag. The script tag is mandatory, and it brings in the loader, the bootstrapper of the runtime. The app element there is the code that will be shown while users are waiting for the files to download at least the first time. By default, they display just loading, but you can put there a GIF. Whatever you put there is the piece, the markup you put in the app element is entirely up to you. The fanciest thing I believe you can do is showing a message, showing an animated GIF. If you put some other text, that will be shown in any page. So it works more or less like an application-wide layout. There is a program CS file, which has more or less the same structure as an ASP.NET Core 3.0 program file. Yeah, there is a specific dedicated Blazor WebAssembly host instead of a web host, different interfaces. The startup is bound through the use Blazor startup instead of use startup, but the structure is the same, and probably there are no needs for you to change anything here. Let's take a look at the startup class, which is pretty much empty, except that in configure you add the root object, which is the app object, and the app string there, the app there, the string in red, maps the name of the tag you have in index.html. According to Microsoft, the way in which you make the binding between the root application object and the external shell of the application may change in the future, but this is code you need to have. This has changed several times since the beginning already. It probably will change also in the future, but it's essentially part of the infrastructure. This code is typically, even in released applications, not going to change that often once its final version is defined. Okay, now, what else? What else? There is this app.razor file, which is more or less the global SX of the past. So it says that the router, so the component responsible for deciding what happens for every external invoked URL and for any in-app action, is inside of the current assembly. Again, also according to Microsoft, take this as is for now. It could change. It will be better documented in the future. So in the end, how do we go to show some data? There are no controllers. The programming model is the programming model of Razor pages, as in ASP.NET Core, which is something in between MVC and simple MVC and web forms. Okay, so Razor pages are nothing new. They've been part of ASP.NET Core since, I think, version 2.0. So essentially, there is a folder called pages, and again, this code is exactly the same as the code you can have in a normal canonical ASP.NET Core 2-point-something and 3 application. So there are a few pages. They changed in recently the extension from CS.HTML to Razor, but it's exactly a CS.HTML syntax. It's a Razor syntax. So pages, all those files are possible endpoints for you to call via URL. So we have this index in particular. Let's take a look at this guy. Okay, so the page at the top sets the URL. So when we call the root of the host website, we'll go here and we'll get exactly that. Notice the survey prompt. What's that? It's an example of a custom component. So survey prompt seems to be ultimately an HTML tag. It's not. It looks like, but it's not. And the survey prompt matches one of the things we have in this shared folder. Here we have this survey prompt.razor, and by clicking here, I get that, I get this, and yeah, this is one of the issues in Visual Studio because it's an unreleased code. So you see here, it looks like a partial view. Conceptually is a partial view. Okay, there are some differences, but you know, to take it simple, consider something like a partial view. So it's a bunch of markup. Title there is in the strong, uses the Razor syntax to refer what? There is no view model, like in ASP.NET Core. But there is a functions section, which is the same function sections you can have in Razor pages. And we use public members in this section decorated with the parameter element, through which we define essentially a way for a parent component to supply parameters to this component. So the title being displayed is an attribute we can set on survey prompt. And if we switch back to an index, we see exactly this. Okay? Okay, let's run the application and see what happens. There is also a main layout over there in the shared folder, which contains the HTML for a nice user interface. It's, in this case, it's just the layout page as we know it from ASP.NET Core. So the main layout, this is the user interface. And notice that there's this imports which sets main layout as the layout for all pages. So the index we have seen earlier is mixed with the structure defined in main layout. And this is the structure of main layout. There is a sidebar with a navigation menu on the right. There's a div of class main with a link, and then with the body. Okay, so this in the end we get a following. Now the interesting thing here is okay, this is this gray part here. This is the survey prompt. If I click on counter, look, localhost/counter, that's the URL, but there is no navigation to the server. If you bring up Fiddler, when you go to counter, nothing happens. And nothing happens even when I click here. And much the same way, nothing happens in terms of server side when I go here. Well, in this particular case, there is, we will see the code in a moment, there is an explicit HTTP call to get the JSON data to populate the table. But it's explicitly done, okay? If the code was static and embedded in the assembly, I could populate the table without involving at all the server. So let's go into some of those files. Let's take the counter, for example, which is the simplest. Here we go. There is this variable called current count, and it's bound to the body of the text. The current count is the value of the variable, and then the button has an on-click attribute bound to increment count, which is a function defined right in the page. So in much the same way, the same pattern as you would use for JavaScript in a classic HTML page, except that we're talking about functions written in C#, with the whole the power of C#, the algorithmic power of C# and the .NET framework core behind C#. This is instead fetch data. Okay. Note the use of inject, ASP.NET Core, to inject a singleton for an instance of HTTP client, the class we're going to use to make an explicit call to a remote endpoint. And HTTP is the name of the instance of type HTTP client. We have in the functions area, we have this local variable called forecasts, which is an array of weather forecasts. Weather forecasts is a POCO defined somewhere. Where is it? Excuse me? Okay, I'm sorry. Sorry, it's defined over there. I usually have it on a separate file, so sorry about that. Yeah, okay, it's defined here. And then there is this onInitAsync, which is the form load. It's the initial method that fires when we get into the page that attempts to await on the HTTP client object for this get JSON async. The red, it's a Visual Studio issue. It works beautifully, the code. We call the URL, which is a sample data with a JSON, which is in this case, we're just calling, and we're making an internal call. We're just pointing to this JSON file here. The JSON is retrieved. Okay, I need to put this in. And then once retrieved, I set forecasts, so the variable is populated, okay? So I make a call and I save to a local variable the data, period. At that point, automatically there is a refresh of the DOM, and refreshing the DOM makes changes to this block where I have a classic table in the body of which there is a for each element forecast in the array called forecasts, and then the TD elements are automatically generated in a popular, familiar data binding style. So it's not really different from the code you would write for populating a classic server-side Razor view, except that it's taking place entirely on the client, on the data we download on a separate call via HTTP, but it could even be via gRPC, for example. Okay, wonderful. Now, let me show you something nicer. This is just the Hello World application. There are a number of aspects of Blazor programming that have not been touched yet. So, for example, authentication, nobody knows how it will happen. Nobody knows. Routing is, for the most part, addressed via the page element in Razor files. Consider that, and this is also something we have learned from core. Consider that we can have parameters here, slash, and I can put route parameter names, which will be automatically bind to any corresponding matching parameter I have in the function section. So it's a sort of model binding style adapted to the Blazor scenario. So if you know how to program ASP.NET MVC and especially ASP.NET MVC core, Blazor is the natural step in the same direction. Okay, this said, let me open up another demo, which shows components. Okay, I have to stop this first. Okay, recent is Blazor comp. Okay, let's run this. Okay, are we going? Yes, good. Yeah, you see the animated GIF instead of just a loading message. Okay, similar page. I have this example, flags of the world. This is an input field, because now in Blazor, realistically, the two most common operations you would do is, number one, posting or getting JSON data to the server, a form that is nothing like submit HTML form, but it's you to collect data, prepare a JSON call, just like exactly what you do in Angular or what you do in ASP.NET apps that simulate the behavior in SPA. So it's everything under your control. So reading, validating, and populating forms and pushing data is the key thing that you do. So dealing with forms and posting data is the most common things you do. Everything else is about the user interface. So I have this input field, and I type something, and I get type ahead behavior. But it's a nice type ahead. So it's not any of the popular type ahead, Twitter type ahead, or Bootstrap-based components. This is the HTML underneath is based on Bootstrap, but it's entirely handmade and in a way Blazor specific. It's a custom component, right? I will show the code in a moment. But yeah, you know, this is something you can easily achieve. So you can go and then choose Russia, and then you will see the flag, and oh, nice. It's too large. The exponential. Okay, fine. Okay, let me pick up Belarus maybe. Okay, which shows an easier to read value for the size of the country. There are a number of interesting things that happen underneath this selection and display, but before that, also I can interop with JavaScript. If I click this button, I have alert, the classic alert showing up. Okay, so these are the two things I will talk about before we end the presentation. Let's start from the simplest, which is the JavaScript interop. Yep, this is the sample page. Notice that this is the red button, and the on-click points to a C# function called invoke.js. Invoke.js sets a message and then uses JS runtime dot invoke async of object. Invoke async, I don't know if it's a bug or something, has no void version. So because the hello JavaScript function, because hello is the name of a JavaScript function I have somewhere, that function doesn't return anything. It's a void method. It's not a function. It's actually a method. I still need to put a T in invoke async. So object at the moment is the standard way of bypassing the problem. But if the hello were returning a string, a number, or whatever, I could use a string int or whatever type is appropriate in invoke async, and I would get back. What I would get back is the C# counterpart of the type returned by JavaScript. So now how I make the two things match, well, there's a little bit of an issue, but for primitive types, it mostly works. So this is one of the other aspects have to be, the interoperability have to be figured out in all details. State has changed. This is a call that explicitly refreshes the DOM. This changes every new release. Sometimes it's mandatory, the next release is not mandatory, it's automatic, then it stops being automatic, it has to be explicitly invoked. You see which one works, okay, in the specific case. Fact is that if you call state as changed, you anyway force the DOM to be refreshed. At the moment, in this version, it's not necessary when you make changes to the model, so it's automatically detected. But yet, if you call it programmatically, you anyway force a refresh of the DOM, an additional refresh of the DOM. Okay, so what is JS runtime? It's an IJS runtime singleton injected. This is an aspect that has changed in 3.0. In earlier version, you had the JS runtime as a singleton defined out of the box. In this case, you have to import via dependency injection directly in the page. Now, what about the JavaScript you want to call? You cannot have it here. So any JavaScript you can call, so the hello function you see there, that same function cannot be placed over there, but must be on a separate file that you link. So in this example, I have the hello.js file, I think, right in the primary layout in this index HTML. Here we go, that's it. Okay? But if you link here a custom JS file, you have type ahead, Bootstrap, any sort of Bootstrap plugin, they work beautifully
as long as you have the appropriate JavaScript to initialize them, or you follow the syntax of those things. So I have a list of articles on MSDN magazine in which I use the Twitter type ahead before they introduced templated components, giving me the great chance to build a native Blazor type ahead component, which is precisely the thing that I'm going to talk about. Here we go. This is the other example I have for you. So it's called flags. It brings in this HTTP client, flags of the world, a bit of bootstrap, and then I have this type ahead component. It has a name. Look, it has a name attribute because my definition of type ahead exposes a name property. So it has nothing to do with the same name, okay, name attribute from HTML. Okay, I did it deliberately just to have a chance to talk about that. But name has nothing to do with the HTML, okay? Placeholder, same story. Has the same name, like an HTML familiar tag, but has nothing to do with that. Autocomplete URL, T item on selection made. How do you read that? Okay, I want to have a type ahead input field with the name P1, with the placeholder name of the country, that uses int/countries, has the URL to get autocomplete items. So automatically int countries will receive the current text in the buffer of the input field and will return a JSON list of objects. A list of what? A list of T item country. An I list of T. And T is the type you specify, so country. So you need to have this country type defined somewhere. When you make a selection, so you type, the autocomplete list pops up. When you make a selection in the list, on selection made event is fired to the outside world for the page to handle that. And show selection is the code, C# code I want to run when I make a click. And when I make a click, I essentially save a country name. I receive the country. I save a country name and country description, a continent name in local variables. And then just to show how it could work in a real world example, I make a call to a remote service to get the details of the country using the ID of the country. I still get back the same country object I already had, but to show how it could work, the pattern that could work in general terms, I did so. Okay, and item template is essentially defines the template of each autocomplete item to show. So in this case, I have a commented line that just shows the country name, but I have a richer version in which I show the country name on a span tag, then an empty space, and then a red text with the continent name. Context is no matter it's in red, but it's the name of the current item in the template. Okay, so okay, so let's take a look at type ahead. Type param is just the name we'll be using for the type we are templating on. In this component, you can have a CSS, you can have a local JavaScript. You don't need JavaScript 99% of the time. You don't really need it. If you catch yourself in the need of JavaScript, you're probably missing some of the key pieces of Blazor. You see that this is an input group with a text where the placeholder, and this is the HTML placeholder attribute set to the placeholder attribute of my custom type ahead component. This is, this is when you need JavaScript because of bugs, okay, in the current implementation. So basically, the on-input HTML DOM event is not mapped. So Blazor doesn't recognize it, but it recognizes on blur. So ideally, you should put try autocomplete on input. But because it doesn't work, okay, Okay, so I put some JavaScript so that blurs and refocus the element. So blur is fired, and in blur I can hook up and call my try autocomplete, which is a C# function that makes the call. Okay, this makes the call. This completes the URL, appends the selected text to the URL, so the current content of the input field, and just calls getJSON-async for the actual URL and gets back an list of the item, which is a country. And then selected text, you see, is one of the parameters, and the value of the input field is set to selected text. So bind is a bidirectional binding. So if you edit the text box, you update the property. You edit the property, you update automatically the user interface. Okay, so I get this. And then there is another part. This is open, which is essentially a Boolean flag, whether the drop-down is visible or not. The drop-down is, this input group append is a drop-down menu that has a header with a number of items. And then for each items, and items is what? Items is an list of the item, which is empty in the beginning and is populated with the output I get from the autocomplete URL. So at that point, for each items received from the server endpoint, I essentially add anchor elements in the drop-down menu. And each element points to this try select item, locally defined. All it does is it closes, hides the drop-down, updates selected text, because selected text can contain a substring. When I click to select a country name, I want the UI of the input field to reflect the name of the selected country. And then I fire the onSelectionMade event. If it's not null, I invoke and pass the item as an argument, which will trigger on the host page the reaction, which in our particular case will show the flag and other information about the selected country. A couple of things to notice here about the public interface of this component. There is the items. This is an internal, both these two guys are internal members. All marked with parameters can be set from the via markup in the host page. So we can set the placeholder, the autocomplete URL, the name, which is not used, selected text just to preset to some string, the input field. Item template is defined as a render fragment of T. If the template doesn't need to have a type, it's just a render fragment instance. Action T item for events you want to fire. And this example basically contains essentially everything about Blazor, given the current state of the technology. Okay, back to for the 5 minutes, the remaining 5 minutes, back to PowerPoint. Okay, so publishing is the same as publishing an ASP.NET application. What you want to do, what Microsoft at the moment recommends you do is publish using the publish to folder option in Visual Studio, and then copy and paste that content to the server. You need to have anyway the standard index HTML page because that is the entry point. So without an index HTML in the www root, you won't go at the moment anywhere further with Blazor. So now, oh, by the way, I'm sorry, I missed a couple of things. So because there's a key difference between the two examples that I showed in terms of their architecture. This one this project is made of three project, client, server, shared. Server is the server-side part. Okay, client is the Blazor application, like the client side. Shared is a DLL, an assembly with classes, weather forecasts, country, that server and client may share. Server is when your server backend is ASP.NET as well. So if you know that it will be your application, you can have in your hands both the client and the server. The server is just can be anything, can be PHP, can be whatever. It doesn't have to be ASP.NET Core, can be whatever else as long as there is an HTTP way to reach it. But if you are building an application from scratch, client and server, you can go with this predefined project template. So you have essentially 3 project types. You have only client, in which it is assumed that any HTTP call is made to existing public URLs that you don't control or unrelated to the application. You have the ASP.NET hosted project, in which you manage client and server as distinct projects anyway, to be deployed independently. And shared is the place, the project that you can really share across client and server, because it's the beauty of C#. So the country is used in both places, but it's defined in one assembly, which is referenced as a regular library in both projects, client and server. Third option, you have server-side Blazor, the first to ship with Core 3.0 in September, October. Basically, Blazor in this case is written as is, so it's 3 blocks, client, server, and shared, but it runs entirely on the server. So the client code runs on the server. So in the beginning, when you start up the application, the WASM is downloaded, some files are downloaded, but the loading time is pretty neat, it's small. It's a fraction of the time it takes for the full load of the application in classic scenarios. Basically, you download only the virtual runtime, the runtime, the virtual machine, but you don't download the assemblies. Okay? And then there is an extra layer on the server-side code that takes care of running the Blazor code client-side, the client code of Blazor on the server, and sends the delta of the HTML DOM via SignalR to the client, making, at the moment at least, selective updates of the DOM. The problem is that it relies on SignalR. So it could be a sort of bottleneck, or at least at the moment, this is the major concern about that. It could be a bottleneck. Okay, Microsoft has Azure SignalR in case you need to scale, but SignalR Core in ASP.NET Core is known to lose connectivity and not to automatically try to reestablish. So the burden of refreshing the page in case the connection is lost is still on you. But these are the three options that you have. And finally, one more comment on, final comment, essentially. It's Silverlight 10 years later, still possible to code in C#. It's an object-oriented language, reasonably easier, much easier to work than JavaScript. Client-centric programming environment, familiar to those who use Angular, but also familiar for the technologies being used to those who use and know very well ASP.NET, especially if you have MVC, Razor, and Core in this order. MVC, Razor, well, actually, Razor, MVC, and the Core past experience, that would be helpful. Okay. Thank you very much for your time. That's it.